This is Algebra 2, Unit 4, Lesson 4, on finding equations of exponential functions. Now, one of the skills that we did in Common Core Algebra 1 was the ability to write equations of exponential functions if you had the starting value and the base, which would be the multiplier growth constants. So let's review the very basic problem, and then we'll expand to a little more complicated problem. So, an exponential function of the form f of x equals a b to the x is presented in the table below. Determine the values of a and b and explain your reasoning. Okay, so it helps if we know what a and b stand for. A in this problem would be our starting value. And when we're doing the starting value, we are actually looking for the y-intercept. So how do we know what the y-intercept is? Well, on our graph, here's our graph. What is the starting value? Is when x equals 0. So that is the y-intercept. So the a value in this case is going to be 5, because that is the y-intercept. Okay, now the b value, the a value is this y-intercept. The b value is the multiplier or the base, or the growth constant it's also called. All right, so the b is the multiplier. So what is happening as we move from point to point here? What's happening here? We are multiplying by 3. We are multiplying by 3. We are multiplying by 3. So every single time we're multiplying by 3, so the multiplier is going to be 3. So that's going to be our b value. So b is 3. So that's our multiplier. So what is the final equation? It's going to be f of x equals our starting value, which is 5, or the y-intercept, times the multiplier. Multiplying by 3, however many times we need to do it, is going to be to the x power. So f of x is equal to 5 times 3 to the x. So the two things you need to know are the y-intercept and the multiplier, and how to find them. All right, now let's look at an exponential function that's a little more complicated when we're only given 2 points and we have to write the equation. So for an exponential function of the form f of x equals a b to the x, it is known that f of 0 equals 8 and f of 3 is equal to 1,000. All right, so use the fact that f of 0 equals 8 to determine the value of a and show your thinking. All right, now remember, the value of a is the y-intercept. A is the y-intercept where x equals 0. So what is the point f of 0 equals 8? Well, isn't that the point 0, 8? When x is 0, y is 8. So that means that a is equal to 8. Now suppose that we didn't know that. Well, why couldn't we plug it into the equation? Y equals a b to the x. Well, y is 8. A we don't know. B is going to be, we don't know, but we know the x value is 0. But what is b to the 0 going to be? It's going to be 1. So this would be a times 1 is equal to 8. So a is equal to 8. So my a value is going to be 8. Okay, now use your answer from part A and the fact that f of 3 equals 1,000 to set up an equation to solve for b. So let's set up the equation. All right, now we know that y equals ab to the x. Well, let's see. We have f of 3 is equal to 1,000. Isn't that the point? X is 3, y is 1,000? Yep. Let's plug it in. 1,000 is y. We figured out that a was 8 times b to the third. Okay, so using the properties of exponents, we have 1,000 equals 8b to the third. All right, now if I want to solve this for b, I need to get rid of the 8, so I'm going to divide by 8. And that gives me b cubed is equal to 125. How do I solve for b? Well, I take the cube root of b cubed. All right, so the cube root of b cubed and the cube root of 125. So that means that b, the cube root of 125, is 5. So b is equal to 5. All right, so I now know what my equation is. All right, so I know that f of x is equal to ab to the x. A is 8, b is 5 raised to the x value. All right, so the x power, I mean. So now this is the equation of this function. So if I want to determine f of 2 now, we know x is 2, would be 8 times 5 squared. All right, so this would be 8 times 25, which is equal to 200. So f of 2 is equal to 200. So by knowing the starting value at another point, we could write the equation and figure out any value that we needed. Now let's try this one. An exponential function exists such that f of 4 is equal to 3 and f of 6 is equal to 48, which the following must be the value of its base. Okay, so let's think about this. We're looking for the base, we are looking for the multiplier. So let's illustrate what this means. F of 4 is equal to 3 is the point for 3. And f of 6 equals 48 is the point 6, 48. So here's what's happening. All right, let me do it this way. We have our x and we have our f of x. All right, so let's say x is 4, y is going to be 3. We don't know what 5 is, but we do know that 6 is going to be 48. All right, so we had to multiply by the same thing twice. All right, so our starting value on this point is going to be 3. How many times did we have to multiply something to get to 48? Well, we had to multiply twice, whatever b was. So we started at 3. We multiplied b twice. Isn't that b squared? And we ended up being 48. So we multiplied b twice. Times b, which would be b squared. All right, let's solve this for b. Divide by 3. B squared is equal to 16. Take square root of both sides. And b would equal 4. So our multiplier must be 4. Let's see if that works. 3 times 4 is 12. 12 times 4 is 48. Yep, that works. So it's number 4. Now let's work with the most generic type of problem. Just like with lines, any two non-vertically aligned points will uniquely determine the equation of an exponential function. As long as you have 2 points for an exponential function, you can write the equation. All right, so the exponential function of the form y equals ab to the x passes through the point 236 and 5, 121.5. By substituting these 2 points in the general form of the exponential, create a system of equations in the constants a and b. All right, so for our first equation, we have y equals ab to the x would be 36 is equal to a times b to the x, which would be 2 squared. All right, my second equation would be 121.5 equals a times b to the 5th, x, y, x, y. All right, now divide these 2 equations to eliminate the constant a. All right, so I'm going to take the larger one, I'll put on top, 121.5 equals a times b to the 5th. And then I have 36 is equal to a times b squared. All right, if I divide these out, what happens to the a's? They just cancel out to be 1. All right, b to the 5th divided by b squared is going to be b to the 3rd. And then if I do 121.5 divided by 36, I get 3.375. So b cubed equals 3.375. All right, how do I solve for b? Well, if I have b cubed is equal to 3.375, I want to take the cube root of both sides. All right, now remember the cube root is to the 1/3 power. I could also do it that way. All right, so if I take the cube root of b cubed and the cube root of 3.375, I can figure out what b is. So if I take the cube root, hit the math key, cube root is number 4, 3.375, I get 1.5. Now remember, you could also do power over root, the cube root. You could also do 3.375 raised to the 1/3 power. That would be its equivalent. You could also do that. You still get 1.5. All right, so b is 1.5. All right, now use your value from c to determine the value of a. State the final equation. All right, so if I have 36, I'm going to use the first equation, equals a times b, 1.5, to the x. So squared. I'm going to use the 2 and 36 for this one. So 36 is equal to a times 1.5 squared, which is 2.25. So that gives me 36 equals 2.25a divided by 2.25, and a is equal to 36 divided by 2.25 is 16. So a is equal to 16. Okay, so now I have enough information to write my equation. I know that a is 16, and I found that b was 1.5. So my equation is going to be y equals a is 16, b is 1.5 to the x. There we go. So all we're doing is figuring out, using points, what our equation is. Now notice here we divided because this is an exponential function. When you do an exponential function, you're multiplying each time. So to undo that, you would have to divide. All right, so basically what we're doing is we're writing two equations, given this, divide them to find b, and then use your b and one of the points to find a. All right, now let's get some practice with this decreasing exponential function. Find the equation of the exponential function shown graph below. Be careful in terms of your exponent manipulation. State your final answer in the form y equals ab to the x. All right, so the first thing we need to do is to write equations using this point and this point. So our general form is y equals ab to the x. Okay, so for this point right here, if I write y equals ab to the x, this is x, this is y. So it will be 128 equals a times b raised to the negative 2. My second equation, using this point, would be 1/2 equals a times b squared. Okay, now when I divide this, I usually do the second one divided by the first one when you do that. So I'm going to take this one, ab squared, divided by 128 equals a times b to the negative 2. Okay, so when I divide, I'm going to divide these numbers, 1/2 divided by 128. So I'll do 0.5 divided by 128. And I end up with 0.00390625. If I hit math, enter, enter, I get 1 over 256. Okay, so this is 1 over 256 equals. All right, the a's are going to cancel. What's b squared divided by b to the negative 2? All right, now remember, this is subtracting, so this is actually 2 minus minus 2. But you could also think of it as this, isn't this going to move up to the top? Yeah, so it's b squared times b squared. This would be b to the 4th. Okay, so I have b to the 4th equals 1 over 256. So what do I have to do? I have to take the 4th root. So I'm going to take the 4th root of 1 over 256 and the 4th root of b to the 4th. The 4th root of b to the 4th is just b. All right, and then I want the 4th root, so I have to hit my math key, pick number 5, and then put my root in. I'm going to do the 4th root of, I'm going to go up and grab this, 1 over 256 is 1/4. So b is equal to 1/4. Okay, so now I know what b is, and now I need to find a. So to find a, y equals ab to the x, pick one of the points to use. I'm going to use either point, it doesn't matter. I'm going to use 1/2. All right, 1/2 is equal to a times 1/4 squared. 1/2 is equal to a times 1/16. And then 1/2 divided by 1/16 or multiplied by 16. I get a is equal to 8. So I multiply by 16 here, multiply by 16 here, and I get a is 8. So my final equation is y equals 8 times 1/4 to the x. Now notice that makes sense because your multiplier is a 4th because this is a decreasing function. Okay, so that is using an exponential function. Let's save number 6 for class the next day.